Alright, Algebra 2. When somebody showed me this formula when I was in high school in Algebra 2 myself, I got angry because they made me factor and factor and factor and complete the square and complete the square and complete the square. And then they showed me the quadratic formula. And then I realized there was a formula to do all of that stuff for me. But it actually comes from completing the square. Now, what I'm about to show you in your notes right now, I don't want you to write down this proof. If you want to, fine, but I don't think it's absolutely necessary that you write down the proof. I'm going to talk you through the proof. I've written it all out. Some of it may or may not make sense to you. Okay, so I pretty much understand that. Let me see if I think I got something wrong here. Yep, I don't know why I have an extra square there. So if you have ax squared plus bx plus c equals 0, and you want to solve that by completing the square. Now I realize some of you are having a difficult time right now because you're thinking, how in the world is he going to complete the square if he's got a's, b's, and c's instead of numbers? Well, that's what hardcore math people can do. They use algebraic skills, but they don't necessarily have to have numbers to do them because they know the principles behind what's going on. So for instance, the first thing I do is I move the c to the other side by subtraction. Okay? And then remember the trick that I've used in completing the square quite a bit, add b squared plus b squared over 4a. And you see that I did that to both sides of the equation. Alright, now the next thing I need to do is I need to look at this right here and pull out this factor. Now that means I'm going to divide everything. So I'm going to divide that by a, I want to divide that by a. And remember, division by a is the same thing as multiplication by 1 over a. Now I know that doesn't make sense to some of you. But pulling out the a would leave me with, those two a's cancel, that's x squared. Then I'd have b over a times x plus b squared times 1 over 4a times a, which is 4a squared. You may or may not follow that. Now on the other side of the equation, what kind of magic did I do? I got a common denominator. This had a denominator of 1, and so all I did was I multiplied the top and the bottom of that by 4a, and I wrote them together. Now that may not make sense to some of you because you haven't thought about adding fractions in a long time. But that's really all I did was I multiplied this by 4a and this by 4a, and then I was able to add them together. Okay, now, in the next part of my process of solving for x, I would have to divide by a. And remember, we said division by a is the same thing as multiplication by 1 over a. And if I do that, then I have 4a times 1a, which makes 4a squared. Now you'll notice that I did this, I took this and I factored it, I reduced it down to its perfect square format. In other words, I took the square root and half of b over a. And half of that would be b over 2a. Just multiplying by half, that's all I did. To get rid of this square, I had to take the square root of both sides so that the top does not simplify, but I know how to take the square root of 4, and I know how to take the square root of a squared, so I get a 2 and an a. Now those of you trying this at home, that minus sign right there stops me from simplifying anything on the top. So don't try to simplify that. On the other side, obviously the square and the square root canceled out. And then I want this term right here to be moved to the other side. Since it's positive, when you move it to the other side, it becomes negative. And then I notice that these two things have the same denominator, and I combine them together. This is called the quadratic formula. And yes, I'm sure you can go online and you can find somebody that's got a video on YouTube singing a song. You can walk down the hall in Homestead and find Mrs. Gamble, and she will have a song, Pop Goes the Weasel. No, I'm not going to sing Pop Goes the Weasel. It's the quadratic formula. It's not that hard to know. If you'd like to make a rap out of it, that might be more interesting to me. or some other song. But Pop Goes the Weasel, not going to do it. Okay, now, so it says the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That is your quadratic formula, and that will give you the solutions. And yes, it's not that hard, and it will go pretty quickly. So for instance, in this particular example, oh, by the way, this is a fabulous way to find the zeros of a function, right? Because when you have 3x squared minus 5x minus 2 equals 0. And by the way, before you can use the quadratic formula, must set equal to 0. If it's not set equal to 0, you cannot use the quadratic formula. Don't try. So that's the first move that I have to do before I use the quadratic formula. So x equals the opposite of negative 5. That would be 5 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so 5 plus or minus square root of the part under the radical actually has a name. The part under the radical is called the discriminant. And in this case, the discriminant, b squared minus 4ac, is actually equal to, let's see, 25 minus, well, there's a negative 4 times a negative 2, that's 8 times 3, that's 24. And it becomes positive because there's 2 negatives. So that's actually 49. The discriminant in this case is 49, which is a nice perfect square. How about that? That does mean that the original equation was factorable. I know some of these you can't factor, but this one was factorable. When the discriminant is a perfect square, you do have something that's factorable, because I know the square root of 49 is 7. So what is 5 plus 7 over 6? Well, that would be 12 over 6. And I know that answer is 2. And then I have 5 minus 7, that's negative 2 over 6, and I know that answer is negative 1/3. So these are my 2 solutions. Try that again here. I'm going to move everything over from this side to the other side. So I have 2x squared plus 6x plus 7 equals 0. And we are going to use a quadratic formula now that we have it set equal to 0. We have the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's negative 6 plus or minus. And if I figure out the calculations for the discriminant, that'd be 36 minus 56, or negative 20. The discriminant is negative 20. That's what we call that thing, the discriminant. Just that part underneath the radical. Now, we do have to simplify this, and sometimes that is the tough part for you guys, is simplifying, because you don't remember how to simplify your radicals. You're looking for perfect squares trapped inside, along with the fact that I see the negative, which is going to create the imaginary number on this question. So we've got negative 6 plus or minus, and I can break that into square root negative 4 and square root 5 all over 4. So negative 6 plus or minus 2i radical 5 over 4. Now, some of you will easily see how to reduce that, and others of you will not. Some of you will see that there's a 2 in the top and a 2 in the bottom. So you will automatically be able to pull out the 2 and get to the answer. Now, some of you are going to need to split it up into 2 separate pieces, because otherwise you'll make a mistake with the same denominator, and then you'll reduce each part, and so you'll write it as negative 3 over 2, because you'll see that you can take a 2 out of the top and the bottom, and here you'll see that you can take a 2 out of the top and bottom, and you'll get I radical 5 over 2. Now these two things are the same, So it doesn't make any difference whether you write it as two separate fractions or as one fraction. So I don't really care if you easily can see how to reduce these, or if you need to split them up and do them separately. It's not going to hurt my feelings one way or the other. Now, remember I was talking more about that thing called the discriminant. And in the book, they tell us why the discriminant is important. Okay? And I'll try to zoom in so it's a little easier to read. The discriminant has some valuable information because it tells me how many times a parabola would cross. See, this particular equation has two real solutions. Well, what does that look like on the graph? Remember, the real solutions are like x-intercepts. Remember we talked about the term zeros? Two real solutions, that's two real zeros. So it's going to cross the x-axis twice. That happens when the discriminant is positive. What about if the discriminant is actually equal to 0? Well, that means that the parabola touches the x-axis only at the vertex. So there's one real solution to the equation, and that means there's one x-intercept, or 1, 0 of the function. And lastly, what happens if this is negative? Well, that means that the graph never touches the x-axis. That means there's no real solutions. It does, however, mean there's two imaginary solutions. Okay, so no real solutions is the equivalent of two imaginary solutions, and you need to be able to make that connection. No real solution, two imaginary solution. They go together. You can't state one without the other. And on the graph, it does mean that there are no x-intercepts. Now, how could I use the discriminant? Well, suppose the question looked like this. It says determine the type and number of solutions. It does not ask me to find the solutions. It only asks me to tell you what type they are and how many they are. So this is a discriminant question. B squared minus 4 times A times C. Well, we have 36 minus 32, which is 4. That's a positive number. As soon as I realize it's a positive number, I know that there are two real solutions. Well, what if it had been 0? Then there'd be one real solution. And if it had been less than 0, some type of negative number, then there would have been no real solutions and two imaginary solutions. But it was all about the discriminant. I didn't have to use the full-blown quadratic formula. All right, now, suppose, this example comes from the book. It's a field hockey example. It says, suppose a player makes a scoot that releases the ball with an upward velocity of 34 feet per second. In other words, they actually hit the ball and it went up in the air at that particular rate, 34 feet per second. So they gave me this equation. This is the equation that the ball's traveling, right? T represents time, H represents the vertical height off the ground. The question is, will the ball ever reach a height of 20 feet? So they're plugging in 20 for H. Now before I use the discriminant, which is part of the quadratic formula, I've got to get it ready for the quadratic formula, so I'm going to set it equal to 0. Now in doing that, now I can just use the discriminant. B squared minus 4 times A times C. Now when I do that and I calculate it, I get negative 124. Negative 100. Obviously that's smaller than 0, so there would be no real solutions. If you're thinking about this in terms of a parabola, let's say the ball went sailing through the air and then landed, right? 20 feet is up here, and the object is never going to touch that. So the parabola never touched the line y equals 20. Never touched it at all. So there's no real solution. So the question, will it ever reach 20 feet? The answer is a big fat no. And we used our discriminant in order to tell us that. If it was 0, let's say the discriminant ended up being 0, then the answer would have been a definite yes, and it would have reached it right at the top of the arc, right at the maximum. But let's suppose it was a positive number. Well, then it was a definite. That would also be a definite yes, because it would have crossed once on the way up and once on the way down. This, however, wasn't one of those situations at all. So that's a section on the quadratic formula, and we'll talk more in class.